Okay,
that's better.
Yeah.
okay, I'm going to run the program again. Can you see that output now?
Yes.
A lot better, yeah.
Okay, good, good. Thank you for that feedback. I needed that feedback. So, any question about this one now?
Mm-mm.
Okay, it goes from 0 to 9. You never do get up to the 10. The loop does run 10 times though, but it's counting from 0 to 9 for the 10 times. Now, that's just the first example of using the range function. We have another one that we can try. Let's see if we can open that up. It's called range 2. Here it is. Now, we can specify 2 values inside the range function, separated by comma. And when we do, the first number represents the start, and the second number represents the stop, but it'll always be -1 from that. So this will actually cycle from 1 to 10 if I use 1, 11. So that's what we've got here is for n in range 1, 11. Now this time, instead of adding up everything, I thought I would add up the odd numbers and the even numbers separately. So I've created 2 new accumulators, one for the odds sum and one for the even sum. Whenever you start with an accumulator, you always initialize it to a value of 0. And then as we cycle through the loop, all of these statements here are inside the loop. What we're going to do is print the value of n like we did before. But then we're going to use an if statement to detect an even number. This is how you detect an even number. Believe it or not, the computer has no idea if 2, 4, 6, and so on are even numbers. The only way the computer could determine that is if the program divides the number by 2 and determines if the remainder is 0. That's what this does. This means if the remainder when you divide by 2 is equal to 0, that's a test for an even number. So now we know that n is an even number, and we'll add it onto the sum with this plus equals operator. That adds n onto the even sum variable. Well, if it's not even, it's got to be odd. So in the else block, we add on to the odd sum. Then when the program's through, we summarize by printing out the 2 sums. So we'll give this one a run. And there's the output we got from that one. Everybody see that okay?
Mm-hmm. Yeah.
Excellent. Excellent. That's great. Yeah. So the sum of the evens is 30. Let's just check that out. 2 plus 4 would be 6, plus 6 plus is 12, plus 8 is 20, plus 10 more is 30. So it looks like it's doing the math properly. So this is actually a pretty good program because not only does it show you how to use the range function to go through a particular range of values, but it also uses if and else to determine the sum of the odd numbers and the sum of the even numbers. This is a very important concept there. That's the test for even. If I wanted to test for odd, I would put a 1 here. If the remainder after you divide by 2 is 1, then you know you have an odd thing. Everybody okay with the logic of this one? Any question about the logic on this one? Do you understand why this program runs the way it does? That's the secret here. This is supposed to go, we're going to cycle a loop that's going to go from 1 to 10, actually. It never will get up to the 11. Any question about this one? Are you guys still here?
Yeah.
Okay. Don't sound too thrilled about it. If you don't understand something, please ask a question. I'll be happy to try and explain it. Okay. All right, we're going to carry on to the next one then. Next one is also uses the range function. And we're going to look at for loop range 3 this time. This one shows you that you can actually have 3 numbers inside of the range function. And when you do that, the first number is the start. We found that out already. The second number is the stop. and I've added one onto this. I want it to stop at 100, so I have to add one onto it to make sure it stops at 100, because we always get one less than that number. And then this third number is the step. So it's start, comma, stop minus 1 step. So this should cycle from 10 to 100 by tens. But we can also have loops that go down. I can also do this. I can have a start of 1000, stop at 0. That'll actually stop at 0. One less than that, you see. And then here's the step, minus 200. So let me run that one. Let's see if you can understand why it runs the way it does. There's the output of that one. Here's the ascending loop, goes from 10 up to 100 by tens. And then the second loop, the descending loop, goes from 1000 down to 0 by 200 each time. So you can have loops go either way. So the main question that I have for you folks then is, do you follow why this runs the way it does? Why does this code generate this output here? If you have a question, please ask me.
Just trying to soak it all in.
Okay.
Yeah.
Okay.
Like that's why I'm quiet, because it's like sometimes you go a little bit fast, but if I'm just quiet, like I can just take time to like process it, and you'll stall a little bit.
Okay.
Yeah.
Well, the other thing is this is being recorded, so you can like watch it at your leisure too. It's, you know, you can start and stop it when you're watching the recording. Yeah. And I'm sorry I'm going a little bit quick. I just want to make sure I get through all these. Got about 8 or 9 programs to show you. So let's look at the next one if you're okay with this one then.
Mm-hmm.
Three numbers here. Like if you want, I could change this. Let's say we change this. Why don't we start at 100, stop at 1000, and make the step 100. So now it should go up by 100. Start at 100 and go up by hundreds. Let's see what happens. I'm going to give that a try. We'll run it. And there's the output. It did go from 100 up to 1000 by 100 each time. Okay. No questions? Well, I'm going to carry on. I'm going to kill this window and start a new window. Next one we want to take a look at is kind of an interesting one, actually. It's how to find something else that you can do with a loop. This one is called squares and cubes. I'm going to open one called squares and cubes here. And a little bit different from the others. We're going to use the range function again. This time, we're going to cycle from 1 to 12. Remember, you never do get to that 13. So the value of n will start at 1 and finish at 12. Now, what I'm going to do inside the loop this time, I'm going to take the value of n and square it. That's what this does. Two stars means exponentiation. So n star star 2 means n squared. N star star 3 means n cubed. And I'm going to store each of those in a variable pow2 and pow3. Then I wanted to make nicely formatted columns. This use of the format function, like you see in this program, is shown at the end of chapter 2. If you didn't catch that, you want to make sure you look back at that at the end of chapter 2. So what we're going to do is use the format function to print the value of n in a column 3 characters wide as an integer. That's what this means. Most of the time in this course, when we used the format function, we were formatting for currency. And you would use like 0.2f, right, to get currency format, the 2 decimal places. Well, you can also format integers with a D instead of an F. And the 3 simply indicates the width of the column that we're going to put the numbers in. Here we're going to show the square in a column 6 characters wide, and the same for the cube. It's going to be in a column 6 characters wide. So let's see what we get for the output of this one when we run this one. There's the output right there. Goes from 1 to 12, as you can see. This is three characters wide here. And then we get the squares in a 6 character wide column, and the cubes in another 6 character wide column. Look at all the output from just a couple of lines of code. This is why programmers love working with loops. You can get so much done with very few statements because you're repeating the statements over and over again. So you can get a lot of output, a lot of calculation can be made with just a few statements. That's what loops are all about. Any question about that one? Anybody?
Yeah, so I was trying to format it as well, but with the tab function, and it seems like the tab function doesn't actually right align it. So we actually need to use this one, right?
This is better. That's right. If you use the \t, you can use the \t, which is a tab character, but then you never know exactly how that's going to line up because \t will always move you 4 characters regardless of how many characters you printed. And so
Yeah.
it's not great for making columns. If you want to really control your columns, you want to use format and specify the width.
So the second print will actually be 7 spaces because it's 1 space for the comma and 6 for
That's absolutely right. Let me just verify that here. Show everybody.
Okay.
I'm going to put my cursor right there on the 12, if you can see that. I'm going to count. 1, 2, 3, 4, 5, 6, 7. Exactly right. Because we get 1 space because of this, right?
Okay.
The comma always gives you 1 space, and then the 16 needs print in a characters in a column 6 characters wide. But we have good control, and everything lines up nicely. And what's great about doing this with this works the same way when you have floating point numbers, and when you do it with floating point numbers, all the decimal places will line up one above the other, which is great.
When will we actually like better to use the tab escape?
Almost never, honestly. Almost never. Yeah, if you really want to format, almost never, I think. You sometimes could use it if you want to generate what's called a tab delimited output file. Something that we'll cover in chapter 6, but pretty much you really don't need to use that tab very often. This gives you much better control. Everybody okay with why that one works the way it does? Pretty cool little program. Lots of output here with hardly any code. Well, I'm going to move on to the next one. Here we go on to the next one. So it's called find multiples. One of the things that we often ask you to do is find multiples. So we do have a program like that here. Here it is. We want to find multiples of an integer in a particular range. So what we want to do to test if x is a multiple of y, to see if x is a multiple of y, here's the test. If x% y equals 0. Like, let me just run a question by everybody. Is 21 a multiple of 7?
Yes.
Yes, it is. Yep, and you know it is because it divides evenly. We tend to say it divides evenly into 7 3 times. But really the test is the remainder 0 when you divide it by 7? That's what the way a computer has to do it. And that's what this means here. If the remainder is 0 when you divide, then you know you have a multiple of y. So in this program, we're going to ask the user to what multiples do you want? And we'll store that in a variable called mult. And then we're going to actually specify a range for the maximum number that we're going to search through. We'll call that range high. This time I thought we'd introduce another feature that's often used with loops, and that's a counter variable. Earlier, we talked about an accumulator variable, which is used to add up values. Well, a counter simply goes up by 1 each time something happens in your loop. And in this case, we want to count how many multiples we find. So we set a counter to 0, and we're going to go through. You'll notice that I'm using here range high plus 1 to make sure that I go through the entire range high that's entered by the user up here. We have to add 1 onto it. And here's the test to see if it's a multiple. If n% mult equals 0, mult is our multiple that we're looking for. That's the test to see if it's a multiple. And if it is, we'll print it out and we'll add 1 onto our counter. So these lines here will be repeated inside the loop. This line here is not inside the loop, it's tabbed out, as you can see. If I tabbed it in one more tab, it would be inside the loop. I don't want that. This is like a summary of what happened here. So let's see what happens when we get this one right. I think I'll try a new window. I'll try a whole new window for this one. Okay, so it starts off by asking multiples of what integer. So let's say I want to find multiples of 17. And I want to go from 1 to, how about from 1 to 300? So that's the biggest number I want to look at all the numbers from 1 to 300. There they are. Those are all multiples of 17. There's the last one. 17 times 17 actually is 289. And if you count these up, I guess there's 17 of them. So we found 17 multiples of 17. That's just coincidental, of course, because of the number 300. We could try that again. I will try that whole program again with different numbers. Let's say we want to find multiples of 13. And we want to examine numbers from 1 to 200. Those are the multiples of 13, and apparently there's 15 of them. Okay, this is a very common thing that you'll be asked to do, is determine if a particular number is a multiple of another number. This is the secret right here. If when you divide by the multiple, you get a remainder of 0, then you know that n is a multiple of that value that you were testing. Any questions about that one? No? Everybody with me still?
Yeah.
Good, okay. Okay. All right, well, I'm going to try a couple more. Let's take a look at, this next one is actually a very cool program. Let's take a look at nested t-table, nested times table. Very simple program as far as how much code is in it. This is going to output a multiplication table. But what it's doing is using what are called nested loops. A nested loop is a loop within a loop. Here you can see we have a loop that's going to go from 1 to 13. And I've used the variable row instead of n this time, because what we're going to get is a table, a set of rows and columns. And so I used row and col for the next loop. Now notice that this loop is inside the first loop because it's tabbed in. And then we're going to, my dog wants out of the room here. We've got the row times the column, and we're going to format that in a column 5 characters wide. So let's run that and see what we get for the output. I think you'll find this one kind of interesting. What you get is an amazing amount of output. There's the output of that program. Get it all on the screen here. Pretty nifty. Goes all the way up to 12. So you can determine, for example, if you wanted to know what 9 times 7 was, you could go to the 9 column and see where the 7 row intersects it, and there's 9 times 7. This is much superior to those tables that I used to have on the back of my notebook when I was in elementary school for memorizing the multiplication tables. If you happen to have a younger sibling who's just learning their multiplication tables, or somebody in your family, you could snip this and print it out for them, and they could study and learn their multiplication tables by looking at this. You folks know how to snip the screen? You folks know how to snip the screen and make a file?
Yeah.
Yeah.
I'm an
Yeah.
expert screen snipper.
Okay. Okay. Well, this is suitable for snipping, and then you could print it out and give it to somebody that's just learning their multiplication tables. But see how it does it? The row goes from 1 to 12, and so does column go from 1 to 12. And here's the first row. So that's the first time that the inner loop runs. The second time the inner loop runs is here. The third time the inner loop runs is here. So the inner loop runs 12 times inside the outer loop. Pretty nifty program. Once again, myself, I get a buzz out of a program like this. Look at all that output from hardly any code. Loops are awesome. Loops are a lot of fun. You should try playing around with them. Try, if you have a little idea of how you might use a loop, try it, see what happens. Okay,
Since the range right there is the same, couldn't you use the second for loop? Couldn't you reference the row target variable in there?
You mean use a variable here instead?
Yeah, you reference the row since it's the same range.
You mean use put row here?
Just row.
Oh, only row?
Yeah.
The only problem with that is it would start at 0.
Oh, okay.
Yeah, that's the only problem with that. I think I'll just leave it like this. Okay, I've got just a couple more to show you. And they all involve the other type of loop, which is called a while loop. There's two kinds of loops, for loops, which we've looked at, and while loops. The first program I want to look at is called while one. Let's take a look at it. Here it is. A while loop, here's what they start like. They look like this. They use the while keyword, and then they have some kind of an expression here, which is going to evaluate to either true or false. You learned about using these relational operators when you studied how to use if and else. Well, we need them for while loops too. And the while loop will continue to run as long as the Boolean expression true. As long as this expression here evaluates as true, the lines that are indented inside the while loop, these two lines, will continue to execute. So this means continue to execute while num is less than 10. We're going to print the value of num. Then we have to add 1 or add something onto num in order for it to eventually get up to 10. If we don't, we'll end up with what's called an endless loop. So this should actually output the numbers from, I believe, from 1 to 9. But you can also go backwards with the while loop. You can start with the higher number and go down, have the loop cycle while num is greater than some value, in this case greater than 0. But then you have to subtract. In this case, we're going to subtract 10 each time. So this should go from 100 down to 0 by 10s. And then finally we have another loop here. So I'm going to run this one. I'm going to try a new window for it. Here's the output of that program. So we get from 1 to 9 from this one. The descending loop goes from 100 down to 0 by 10s. because we're subtracting. That minus equals there, that means subtract 10 from num each time. And another loop here. No, this loop skipped. This loop is skipped. These lines do not execute. Well, one of them is a comment, but there's no printing from this one, and that's because this is false immediately. Num is not less than 10, it's 25. So because that evaluates as false, the loop is skipped. So that's an important feature of a while loop. A while loop might never run. If the condition is false from the start, it might not ever run at all. The other thing that you have to watch out for with while loops is it's very easy to get an endless loop. And I'll show you what I mean by commenting out this line. If I comment out this line and run this program, I'll get very different output. There we go. It's going to print forever. If this is an endless loop, it'll continue to print 1 until my computer goes down or the power goes off or the battery dies or whatever. It's just going to continue to print 1. It's a common programming mistake with while loops. You have to modify the value of this variable so that it eventually the Boolean expression is false. Okay, so that's how while loops work. Now, we've got one more to take a look at. Let's look at another while loop. Look at while 2. Here's while 2. A while loop is good for an indefinite number of cycles. Usually with the for loop, you know exactly how many times you want the loop to cycle, and you specify that when you're creating the for loop statement. But a while loop is also good for an indefinite number of cycles when you're not sure how many times the loop should cycle when the program starts. And that's really good for user inputs inside the loop. Take a look at this one. We're going to, in this case, find square roots of whatever the user enters as input. But in order for this to work, we have to start with an initial input here. That's called a priming read. So this line here is called a priming read. We're asking the user for an integer. Now, look at the while expression. This means while num is not equal to 0. This is your not equal to operator. So as long as num is not 0, this loop should continue to cycle. So it's possible if we enter a 0, this loop will be skipped. If we enter anything other than 0, it should calculate the square root. Now, I'm calculating the square root by using the exponent of 0.5. Some of you may know from math class that that's the same thing as finding the square root. If you take something to the 1/2 power, that finds the square root. So then we can print out the square root. I'll print it out to 3 decimal places using the 0.3f. Now, we have to have, in order to prevent an endless loop, we have to have another read. And this is the continuation read. It's the very same as the priming read, but it's at the end of the loop. So I'm going to run this. There we go. And I'm going to enter a 0. We get nothing, no output. Skip the loop completely, right? Because while num is not equal to 0, evaluates as false, so the loop is skipped because I did enter a 0. Let's try it with something more useful. Okay, so I'll try 12. Apparently that's the square root of 12. Now notice it continues to run the loop because, as you can see the flashing cursor here, that means the program's still running. And that's the continuation read that's asking me for another number. So I will enter 23. And we'll try another one. We'll try 44. We'll try 81. We know what that should be. Yeah, there's your 9.0 for 81, of course. So stop it and just enter 0. So we can, this is good for a case. A while loop is great when you don't know how many times the user wants to use the program. I used it, looks like 5 times here. And the only condition is keep going while num is not equal to 0. So that's what while loops are good for. An indefinite number of cycles, and particularly for user inputs inside the loop. One more final program to show you. I'm going to kill this window. And this one is very similar. This one's called while 3, but this one is for entering a string instead of a number, asking the user to enter a number. So yeah, we're going to use string inputs here. We're going to ask the user to enter a string. So we have to slightly modify the Boolean expression. The book calls these while loops condition controlled loops, by the way. You still begin with the priming read. In this case, we're going to write a program that asks the user to enter the name of the person who created Python. And of course, we know that that's Guido. So we'll continue. Look at the difference in the expression here. While name does not equal empty string. That's what you would get if you press enter. If you press enter on an input like this, that's accepting a string, you'll get an empty string. And this is the test. Keep going while the name is not equal to an empty string. In other words, while the user hasn't pressed enter. So we'll check to see if the name is Guido, and if it is, we will print out a positive response. And then we'll set the name to be an empty string, so that'll stop the loop. If the user doesn't get the name right, we'll ask the user for another try. There's the continuation loop. So I'm going to run that one. And we'll get it wrong a couple times here. I'll just enter some garbage. Was it Bill Gates? No. Was it Steve Jobs? No. Was it Guido? I'll get that right. Was it Guido? Yes, it was. So, once again, an indefinite number of cycles. We didn't know how many times it would take for the user to get the right answer. So that's a great place to use a while loop. Well, that was about 40 minutes. Went through pretty much everything in the chapter in 40 minutes there. I know that's pretty fast. So we've got time left. So I'm wide open for any questions you might have. You can even ask a question about, doesn't even have to be about loops.
Right there, the name you set it up to be equal string. That's like a sentinel. So just like to stop.
It's not exactly a sentinel. A sentinel is more like you're looking for a particular value. Like let's say we had like a secret name. Enter a name, and we could maybe be looking for a particular name that was a secret name, and that would be the one that would be considered a sentinel. It's somewhat like a sentinel in a way. The empty string is sort of like a sentinel. Like we could be looking here for bozo or something like that, and if the user entered bozo, we could maybe make a sound or something. That would be more like a sentinel, I think, something like that. Okay. Any other questions? Any questions about any of these, any program or anything else? How about the chapter 3, which is all about if and else? Any questions there? Anything else about Python that we can help you with?
I was working with the nested loops one, and the diagonal kind of like asterisk looking one.
Yes, right.
Okay, and for that one, I was not sure like how it actually works. Like the iteration inside of the for loop. Like
Right.
it goes first, it goes to the row, and then it kind of like it iterates as many times as the range you put for the column one inside.
Yeah, that's right. Yeah, there's a couple of examples in the book near the end of the chapter. See if I can find them here. Yeah, there's a triangle. Okay, so if you want to print a triangle like that, it's done with nested loops. Notice here we've got two nested loops. There's a 4R in range base size, which indicates how many lines you want. And then for C in range R plus 1, because you have to remember you always have to add 1 onto that if you want to get a particular number. And this print ends the line. It's actually very similar to the multiplication table, the times table that we made. Nested loops, they're very powerful. Any other questions, anybody? But anything at all in this chapter? I don't know if you've tried any of the turtle stuff. It's kind of fun. Look at that. That's almost the same as your assignment, right? It's almost the same as your assignment. You want to print a diagonal line.
Yeah,
There's
so
that.
kind of like how it works is that the innermost loop will kind of like iterate the amount of times that it says. So it'll print the statement that it's there, and once the count goes to 0, then it goes back to the outermost loop. Is that how it kind of works, right?
Yeah, it's actually once the range gets up to R minus 1, then it goes back to the what you could do. Let's see here. I'm going to go back to that other nested loop program if I can find it for a second here. Yeah, okay, this one here. I'll just make a variation on this one. I'll call it, I'll just call it nested to illustrate something about nesting. What we'll do is we'll just print, instead of row times column, we'll just print the row and the column. Row, comma, column. Okay, and then we'll put the end operator in so that we cancel the new line. Okay, so let's just see what we get from that. Check the output here. I'm just going to call this nested. I've saved it as nested, so here we go. I guess what we need, yeah. So the first time it's 1, 1, then 1, 2, then 1, 3, then 1, 4, then 1, 5, all the way up to 1, 12. Then it's 2, 1, 2, all the way up to 2, 12. And then 3, 1, all the way up to 3, 12. Maybe that helps you understand a little bit better how the nested loop works. There's the value of in the outer loop, and then that's used all the way through the inner loop. 5 is multiplied by all the values of the inner loop, all the way through up to 12. Hope that helps.
Oh, okay.
CJ's on the island. Head south on Forest Lake Boulevard South.
Any other questions at all about Python? We've got a few minutes remaining. Anybody?
Professor, you said that these videos are all recorded.
Yeah,
I'm
that's
at
right.
work right now, so how do I access it?
I'll have to. Yeah, that's a good question. I guess you have to email me. If you email me, I'll send it to you. If anybody that's in my classes, I'll be posting it in my courses for my class, but maybe some of you folks aren't in my class. I'm not sure.
Okay, thank you.
If that's the case, if you send me an email, yorth.brad@spcollege.edu, I will happily send you a link to where you can see the video.
And you'll send us the files too?
Yes, I will send you the files if you ask me. Right, absolutely. All of these.
Oh. If you're sending those, we got to ask, or you're just going to put them in the thing? I definitely will.
I'll put them in my courses for my courses, for
Okay.
my classes, but if you're not in my class,
Oh, okay.
I'm not sure how I'm going to get to you.
All right, cool. Because I'm looking forward to digging through that.
Okay, fine. Yep, we'll definitely do that.
Cool.
Let's see, I've got them all in a folder here, and I'm just going to zip that folder up and send that along.
All right, cool.
Okay. Any other questions, folks? Anything at all?
Well, I just want to say thank you for honestly doing this, because this really, really is helpful, having this extra feedback and just going through it one by one, and then again being able to like review it. So I just want to say thank you on behalf, I'm sure, of the whole class. So I really appreciate this.
Thank
It definitely
you.
helps me.
Well, you're welcome. I'm sorry I have to go so quickly to get through them all. I suppose ultimately the best way to do this would be if you like studied up the chapter a bit first, and then I could just show you a couple of examples and you could ask more questions. Might be better. Next week, we're going to do chapter 5, which is on functions. It's a big one.
Tomorrow we have no class too, right?
That's right. If you're one of my students tomorrow, there are no classes. There's no classes for anybody tomorrow. All classes are canceled tomorrow. It's the professional development day for the entire college. Yeah, once a year we all meet and we all go to school. We get the other side of the coin. We get to suffer like you folks. Anything else, folks, at all? I just want to make sure you're okay with the ebook. The thing, or not the ebook. I guess you don't have the ebook. I've lost the ebook, unfortunately. But you want to make sure you take a look at the end of chapter 2 about the formatting. I'm not sure if I went over that carefully enough. At the very end of chapter 2, particularly I give the page references here before the turtle stuff. You want to take a look at from page 68 all the way through to 71, actually all the way through to 73. From 68 through 73 explains how to use format, and it shows you how to create columns like we did today. Okay. I'm just going to run this one here again. And the reason I wanted to do that, I just wanted to show you that you can always test lines of code right here in the interactive window, right? Like say, for instance, if you try 15% 3 equals 0, true, right? That's the test to see if 15 is a multiple of 3. Right? The remainder, when you divide 15 by 3, if it's equal to 0, that tells you that 15 is a multiple of 3. Now, if I can arrow up to this line and repeat it by pressing enter. And if I try 1. That's false, of course. But if I try 16% 3 equals 1, that of course is true. The remainder is 1. Now that's not a test for odd or even. But,
Professor?
yeah.
So just to confirm, so you go up to the arrows and then you just click, like
Yeah.
basically you just click next to the 15 and then you hit enter and then you just reprinted it?
Yeah, I can go to any line I want here and press enter, and it'll come back, and then I can edit it,
Okay.
and then press enter again. So it's
Thank
kind
you.
of a neat little way to test things.
Okay.
You can even do things like this. Print 12 equals 9 plus 3. True. 12 is equal to 9 plus 3.
Okay,
That
thank
sounds
you.
pretty cool that way. You can even just do multiplication if you wanted to, or any other math operation. So you can sort of use it as a calculator.
Bless you.
Okay. Well, I guess we're done. Our time is going to run out in a minute. So if there's no more questions, let's call it a day. And keep busy. Make sure you know what to do if you're having trouble. If you're having trouble, get in touch with your professor, and you can probably send your professor the file that's not working for you as an attachment, or paste it in. Sometimes if it's just a little bit of code, you could paste it into the email, and probably your professor will get back to you in a day or so, or hopefully even sooner than that. Remember too, that every campus has a learning support center where you should be able to find somebody that can help you. Okay, I'm going to call it a day. Hang in there with Python. Brad out.
Thank you. Thank you. Thank you. Have a good night.
Bye-bye.